Welcome back to part 2 of this free player controller course. In part 1, we built a basic first and third person controller using Unity's new input system and Cinemachine, but at the moment we don't have any types of states or animations. In part 2, we're going to be adding animations to our player, including idling, running, and sprinting animations using a blend tree, which is going to make them blend together seamlessly depending on our player's velocity. Additionally, we'll be creating a basic Enum state machine to keep track of our state that our player's in, and we'll be decentralizing the state machine from our player controller to enforce good coding architecture. Let's go ahead and get started. Alright, so we're back in our project and we're just going to jump straight into animation. Now you might notice that our player's controller already has an animator component on it. We want to actually just replace this animator controller with our own here. So let's create an animations folder inside our final character controller folder. Then we can make an animator controller. I'll name it player animator. Let's go ahead and apply any changes to our prefab in the hierarchy. Then for both of our prefabs in the project folder, we'll replace the animator controller with our player animator. Okay, so I'm gonna go ahead and open up the animator tab and we have our empty animator controller. The first thing that we need is to add a new substate machine. The reason I'm adding a substate machine here is I want to contain all of the animation logic for our player's movement inside of the substate machine. And later on, we can add additional logic like attacking or foraging in the same animator, but outside of this substate machine. This will become much more clear later on, but for now, we're just going to be working inside of the substate machine, which I'm calling locomotion. And on entry, we'll just make a transition to it. Inside our substate machine, let's make a new blend tree, which I'm also just going to call locomotion. Now we can double click into this blend tree. And now we have to choose between which blend type that we want. If you want, you can look up the different types, but 2D freeform directional is the one that we're going to be working with for 2D based movement input. We need to feed in 2 parameters for this blend tree. So let's create them in our animator. Head over to the parameters tab and add a flow. We're going to call the first one input X, then one more, which we'll call input Y. Now in our blend tree, we can select 2 parameters. So what is a blend tree exactly? I have a video that explains a little more on this, which I'll link above, but essentially it's a group of animations that will blend together seamlessly based on some parameters. So let's start adding to our group of animations, or motions is what they're called in a blend tree here. So we'll add a motion field and then we can start by dragging in idle. We're going to want a bunch of different animations for all different directions of movement. We need things like run backwards left, run backwards right, and we'll be adding in strafing and obviously running forward as well. I'm going to move all of our animations that we plan on using into our own final character controller folder so we can keep this player controller as a single consolidated package. Then we can start creating a bunch of motion fields and dragging in each animation. Now comes the final part of our setup for our blend tree. We need to set the correct positions for our input X and input Y for each animation. That means for something like idle, we want to set it to 0, 0 because that's when we have no input. But something like run backwards would be when we're not moving in the X direction, but we're moving at -1 in the Y direction. Keep in mind, we're going to normalize all these values to 1 for our run speed in C#. Running on diagonals is actually a bit tricky. Our input system will take care of this for us, but when we run on a diagonal, we'll find that our maximum input X and input Y are 0.707. That's because of something called trigonometry, which means we need to divide 1 by the square root of 2 to get to that answer. Anyways, for our diagonal elements, we'll set them as 0.707. This is especially important to remember, actually, if you want to include controller support. Really important for that. So I'll go ahead and set the rest of these real quick, and what the result should look like is this circle of blue points with the idle point in the middle. So let me just show you how this is going to work graphically. We can play around with our input X and input Y values with these sliders, and you'll see the red dot is actually moving around, which represents our current values in the 2D space. So whichever blue dot that the red dot is closest to is the dominant animation that plays. You'll see the strengths of the animations represented by the size of the blue circles, which means that you can actually be playing some kind of average between 2 or more animations at the same time. This is exactly what makes blend trees so powerful. it results in extremely smooth and seamless transitions. It's definitely the way to go if you want a nice professional touch. So let me actually go into play mode real quick and show you what this looks like. We can drag around our input X and input Y. It's highlighting the dominant animations in our animator, and we can see that our player smoothly transitions between different types of animations. Okay, so our blend tree is behaving correctly. Also, I did just realize that it looks like our animations folder is actually outside of the final character controller folder, so I'm just gonna move this inside here real quick, and that's where it should be. So now we're gonna start hooking up all of these animations via scripting. But first, we need a type of a way to keep track of our player movement state. Now there's a ton of ways to do this with varying levels of complexity. For example, we could use something called a state pattern. State patterns are a complex topic, and while they're generally the best way of implementing state-dependent logic, it's more complex and unnecessary for what we're trying to build. So we're gonna do the next best thing, which is way simpler in my opinion. And it also achieves essentially the same result. This is called an Enum state machine. Let's start by creating two new scripts, one named player state and another named player animation. Let's open up the player state and add a namespace real quick. So this script is basically just gonna keep track of what movement state our player is currently in and also provides some convenience function for us. This is an enum-based state machine that we're making, so let's make a public enum named player movement. And then we'll go ahead and give us a bunch of standard movement states like idling, walking, running, sprinting, jumping, falling, and strafing. So why have both jumping and falling? Well, we're gonna be playing two different animations based off of those two states. So to me, it makes adding in animations the easiest process. So here's some new syntax for you. We're gonna do brackets field colon serialized field. And then we're gonna make a public player movement state called current player movement state. So why this kind of odd syntax? Well, basically, you have to do this if you want to serialize a property in Unity's editor. I'm making this property because, again, I don't want anybody to be able to set the state from outside of the class. All changes will happen in the player state class so we can keep track of it. But I also want to be able to view the current state in the editor for easy debugging, hence why I've added the serialized field portion. If we go back into the editor and add our player state and player animation scripts to our player, you can now see that our current state is being displayed in the editor. So this is going to be super convenient for us in the future for debugging purposes. Next, let's head into our animation script, adding the namespace again, and we're going to start by serializing a private member field for our animator. Then let's get a reference to our player locomotion input as well. Now the next thing is a really cool trick for working with animators. We're basically gonna create a reference to animator parameters that we set up in Unity. This is useful because then we don't have to remember the exact string every time we wanna call it. We can just create a single reference, and it also will autocomplete with IntelliSense now, which is just a little added bonus. So we've created a reference to our input X and input Y in the animator. Now let's set up our reference to player locomotion in Awake real quick and add in the update function. I'm going to create a function specifically for updating our animation state. Let's call it update animation state. Inside of this method, we want to have an input target. For now, we're just going to set the input target to our movement input exactly. Then we're going to set the animator parameters to the X and Y components of our target input. All right, back in Unity, let's make sure to hook up our animator to the animator script. So this is really cool. We're already seeing our idle animation. Then when we move around, our blend tree is responding to the input X and input Y parameters we set. And we can see that we're running backwards, we're running forwards, and we're actually able to also see the strafing animations. Let's even take a quick look at what our blend tree is doing. You can see it's highlighting the current animation that we're playing, but there's definitely a few problems going on. The first one I noticed is that our left run and right run animations are actually in the wrong direction. I believe that is actually an error from this asset pack, but we can go ahead and correct it pretty easily. One way to do this is just click the mirror button inside the blend tree, and now you can see that it's working properly again. But just to be complete and cause less confusion in the future, I'm actually going to change the names of these animations instead. So we can go into our project files and just swap these names on these objects, but we actually also have to go into the inspector and change the animation name itself because these are all part of an exported model or FBX file. Okay, now with those name changes, we just gotta swap their places in the blend tree and also make sure to uncheck the mirror checkbox if you check that. And in play mode, you can now see everything is working correctly. Let's talk about one more issue. The blend tree isn't really blending, it's just instantly changing between different animations. So that's because you can see that the input X and input Y parameters are just getting immediately set to new values. What we need to do is slowly ramp them or lerp them between their old and new values. Let's do this now. Go back to our animation script, add in a new float named locomotion blend speed, and we also need a way to store our blend tree's current input value, so let's create a vector3 named current blend input. In the update animation state, we can set our current blend input to a new lerped value using vector3.lerp, put our current value first, our target value, which is our current input, then our lerp speed times time.delta time. And going back into Unity, let's quickly adjust our blend speed to 4. You can now watch these sliders in real time lerping between the current and target values, and our character animation looks much smoother. We do have a problem though, which is our movement state is not reflecting our actual state, so let's start building up our state machine. Open our player state up and let's add in a new method named setPlayerMovementState. This will take in a new value and set it to our current player movement state property, and then back in our player controller, let's start organizing our code a bit here. Take everything in the update method and let's make a new function called handle lateral movement. Let's paste all this in there and we can then call the method from update. Next, we'll handle all of our state logic. Let's make a function called updateMovementState, and we're gonna need a reference to our player state class. So let's get an instance of that in awake. We're gonna make a number of checks here in our update movement state. So the first thing that we'll check is whether or not there is lateral movement input. We can create a Boolean and ask whether our player locomotion's input movement is equal, or not equal, I should say here, to vector2.0. Now let's check if we're currently moving laterally. For this, I'm gonna actually make a function that will return true or false. So let's make our new function called isMovingLaterally. All we have to do here is get our current lateral velocity as the X and Z component of our character controller's velocity. Then we'll just return the Boolean expression, is lateral velocity's magnitude greater than 0? So this is all great, but we're actually introducing a subtle bug by making this check. Sometimes our velocity might not be exactly 0, but still extremely small. So I'm gonna actually create a public float named moving threshold and set it to a small value. If we're below this moving threshold, we're just gonna go ahead and say that we're essentially not moving and we're in the idle state. Okay, so actually I didn't put a capital I here, so just make sure you do that. It wasn't recognizing that function, but back in the isMovingLaterally function, we now need to modify this so that the lateral velocity's magnitude is greater than our moving threshold instead. Before we go any further, our player controller class is getting pretty lengthy and complicated, so I want to go ahead and organize this into regions. So regions are folds or categories of code that you can quickly minimize and expand. So first, let's make a region for our class variables, then a region for our startup methods, a region for our update logic, our late update logic, and then finally our state checks. Cool, so this is definitely going to be a lot more manageable now. Let's go back into our update movement state. And here we're just going to perform some logic to figure out what our current movement state is. Now you can actually see Visual Studio isn't recognizing player movement state. That's because I messed up a little bit accidentally. So if we go back into our player state file, you can see I put the player movement state inside of the player state class. I actually do not want to do this, and instead I want to put it outside. The reason being I want to easily access this enum from other classes without typing the player state declaration. So now we're going to figure out our current lateral state. We do this using a ternary operator. So if we're moving laterally or there is input movement, then we're in the running state, else we're in the idling state. Then we're simply going to set the player state using the exposed method setPlayerMovementState. Let's check out the result of this in Unity. So now in play mode, if you turn your attention to the player state script, you can see that our player state is updating properly. This is going to be incredibly useful going forward when debugging our player movement. Now that we have our Enum state machine and our animations working, let's start building on our foundation and add in sprinting. Open up your player controls input and create a new action named toggle sprint. Let's keep the default properties, then for our binding path, I'm going to use left shift. Your console should throw an error when you save this, so navigate to the player locomotion input script and implement this function. Now we have our onToggle sprint function when left shift is pressed. Let's make a serialized field, which is going to be essentially a setting people can change for how sprint works in the game. We're going to name this hold to sprint. If hold to sprint is true, then we will need to keep holding shift in order to keep on sprinting. But if we set this to false, then sprint is just toggled on by pressing shift. Let's build this logic in now. Create a new public property named sprint toggled on. Then inside our toggle sprint function, if we hold shift or context.performed is true, then we can change our sprint toggled on value. Now this is going to depend on our hold to sprint setting. So if hold to sprint is true, or if sprint toggled on is currently false, then we're sprinting. We also need to handle the case for when we release the shift key. So if context.canceled is true, then sprint toggled on is only true if hold to sprint setting is false and we're currently sprinting, or if sprint toggled on is true. I know that was kind of a lot, but this will encapsulate the entire behavior that we need. Before our sprinting can work, we need to head back into our player controller and add in our sprint settings. Let's create a new public float, sprint acceleration, and sprint speed. Next, we need to add this into our state checks, so let's create a boolean called isSprinting, which is true if our sprint toggled on is true and we're moving laterally. Also, I'm just commenting this here real quick, but the order of these calls matters, so we don't want to forget that later on. We need additional logic to keep track of our lateral state, so I'm going to add into this ternary operator here. The easiest way to do this is just create a new line after the equal sign, and let's add in a new ternary statement. So now this reads, if we're sprinting, then our current movement state is sprinting, else we have our previous logic for running and idling. The last thing that we need to change is our player's speed depending on what state we're in. So we're making sure to update our movement state before we handle any movement, which means we can take advantage of our player's state for implementing simple logic into our movement functions. So I'm going to create a quick reference for our current states in the form of some local Boolean variables. We'll have isSprinting Boolean, which is set to true if our current player movement state is sprinting. Now, I know you might be thinking this seems a little redundant, and you're totally right, but I would argue that creating this local Boolean here makes our code much more readable, so that's just why I'm doing it. I'm now going to create a variable named lateral acceleration, and using a ternary operator if we're sprinting, we set it to our sprint acceleration, obviously, else we set it to our run acceleration. Let's also make a float named clamp lateral magnitude. If we're sprinting, this is the sprint speed, else it's the run speed. Then the last change is instead of the run speed here, we need to now choose our clamp lateral magnitude. And instead of run acceleration, we obviously use lateral acceleration. And we'll add in just a quick comment here. This is the state dependent acceleration and speed. Save this, head into Unity, and for some reason, I started getting a bug here with my second audio listener, so just make sure that you did turn that off on your dummy camera if you haven't. Let me also adjust some settings, so I'll set the sprint acceleration to 50, run acceleration to 35, and bring down the drag to about 15. And then let's head into play mode. Hopefully you guys can see this, but we are toggling between sprinting and running, and there definitely is a speed change, so everything is working correctly. Currently though, our running animation is playing for our sprinting speed, so let's actually add into our blend tree to solve this. Now we could just add in another motion to our blend tree, but unfortunately most of the time the easy way out isn't the best way out. So instead, the best way to approach all of our locomotion animation is to start splitting up our blend trees into nested blend trees. I know this is a pain, but it's the best way to do this in the long term, trust me. So what I'm going to do here is create a new motion, but instead of a single animation, we're going to make this new motion an actual blend tree. So now we have nested blend trees here. Let's name this one sprint, set the blend type to 2D freeform directional, and we'll use the same input X and input Y for our parameters. The annoying part here is we kind of got to rebuild our whole blend tree for the running part. So create another blend tree motion, name it run, and enter in all the old settings here. So I'm just going to do this really quick, delete all the old blend tree motions and add them into our run blend tree. We've already seen this all before, so I'll just accelerate this. And okay, so now we have successfully built our nested blend tree with a run and sprint blend tree. The next thing that we need to do is add in a sprint animation to our sprint blend tree. Unfortunately, this asset pack did not come with a sprint animation, But what's really cool about Unity, I mean, this is a really great feature, is when a character model is set up correctly, it uses character avatars, which means we can take animations from free sites like Mixamo and just straight up apply them to our character, and it just works. So to save you all a bunch of time, I've compiled a folder of animations that we can import into our project. This is going to be freely available on my Patreon, so just navigate to my Patreon link in the description and download this character controller assets.zip. So part of who I am and what this channel represents is I always want to release my assets for free for you guys. Unfortunately, I've been doing this for almost a year now, and I still have 0 paid members on Patreon. I know many of you don't have money to spare, which is why I release everything for free. But if you are able to subscribe on Patreon, even the lowest tier really helps me continue making this free content for all of you. So, again, this is free though, so go ahead and now download the zip, extract the contents, and we're gonna drag the 4 animation files into our Unity animations folder. Let's add 3 motions to our sprint blend tree and drag in sprint, sprint left, and sprint left again. And the nice thing here is we can just check this mirrored animation for our sprint right animation. I'll set the sprint forward values to 0 and 1.5, a little more than our run speed. Then we need to do a quick calculation for what our diagonals should be, which is 1.5 divided by the square root of 2. So let's enter in 1.06 for those diagonals. Our blend tree is set now, but we need to add in a unique parameter to help switch between our run and sprint blend trees. I'll call this input magnitude, and now we gotta hook this up in our animation script. First, add a private static int input magnitude hash from our input magnitude parameter. Then I'll get a local reference to it if we're sprinting. Oh, actually, first we need to get a reference to our player state, so let's hook that up real quick. Now we type in player state.current movement state equals sprinting as our Boolean expression. This might not seem like the best way to do it, so we're gonna do a ternary statement here, and if we're sprinting, we multiply our input target by 1.5, the same amount in our blend tree. I probably will come back and revisit this, but we're gonna, basically just use this for now. So finally, set the animator input magnitude to our current input magnitude, and honestly, this line is a bit too redundant here, so let's just get rid of it. Back in our animator, we need to make sure our locomotion blend tree uses our input magnitude parameter, so switch the blend tree type to 1D, since it's just based off of a single parameter now. If our input magnitude is up at 1.5, then we're going to be using the sprint blend tree. Otherwise, we blend to our run blend tree. Finally, let's test this out. Let's go into play mode, and we see that we start by running. You can see it's going into the run blend tree. Then we sprint, and obviously we have our sprint animation taking effect. So it looks like everything is working. There's definitely a couple problems here, like when we sprint backwards or diagonally backwards, we're getting some strange looking animations. But don't worry, we're going to take care of those issues later in the series. Here is one final demo showing what we've got now. We have a character who smoothly blends between idle and run animations. We created a sprint state, which we can either hold to activate or instead change to a toggle-based input. And our sprint state uses sprinting animations for both forward and diagonal movement. I hope you guys are enjoying this series. Don't forget to like and subscribe if you haven't already, and I'll see you in the next one. Peace.